All right, now we have part 5. So we talked about density, right? We talked about the concept of density. Now, how do we calculate density? All right. So if I want to find out the density of a rock, I need two things, right? If I want to find the density, I need two things. I need the mass of the rock and I need the volume. I need the amount of space that it takes up. So if I have these two things, here's what I do. I take the mass and I divide by the volume. Right? Do you see this fraction bar in the middle? The fraction bar represents the division sign. So I take the mass, right, which is in kilograms or grams, and I divide by the volume, which is usually in milliliters or cubic centimeters. So let's take a look at this example. For a 20-gram mass, right? So 20-gram mass. This 20 goes up here on the top, right? It goes up here on the top. So 20 divided by the volume. So what is the volume? The volume is 5. So we just do 20 divided by 5, and that gives us 4. So the density is 4. Now, this object will not float in water. What is the reason? Because the density of water is 1, exactly 1 gram per centimeter cubed. So anything that is less than 1 will float, like a pumice rock. Anything that is more than 1, like this object, will sink. So this formula over here, density equals mass divided by volume, is used to find density. If I have the mass and the volume, if one of these is missing, then I have to go find that first. Let's say I don't have the volume. Well, I have to go find the volume first and then come back and I put it in here and I find the density. Okay. Now look over here on the left, right? If you look over here on the left, you see 3 different formulas. So the formula that we just used is formula number 3. All right. However, we can also find the volume and the mass in a similar way. So look at the first formula. Let's suppose I have the mass and I have the density. Well, then I can take mass and divide by density to find the volume. Okay. Now, the only way that I can use this formula is if I have the mass and the density. Okay. If I'm lacking one of these things, let's say I want to find the volume of an object. I have its mass, but I don't have its density, then I cannot use this formula. Okay, that's very important. So I can only use this formula if I have the mass and the density. If one of those is missing, then I have to go use some other method of finding the volume. I have to go measure it using the water displacement method that we talked about, or by using the formula that we talked about. All right. Same thing for mass. Let's say I have the density and I have the volume. Then I could use this formula to find the mass. Now let's say I don't know the mass. I'm trying to find the mass, but I also am missing either the density or the volume. Well, in that case, I cannot use this formula. I have to go take that object and go put it on a scale and go measure it that way. All right. So these two problems, you will use those formulas to find out the answer, to find out the density. So the first one, it says pumice is an igneous volcanic rock formed by the rapid cooling of lava. So we talked about this pumice in the class. What is the density? Okay, so we're looking for density. What is the density of a 49.8 gram piece of pumice? So what is 49.8 grams? That's the mass. Remember, grams is mass. That has a volume of 83 centimeters cubed. So they're giving us the mass and the volume, and we have to find the density. So you're going to use the right formula to find the density. Same thing with this one. We have obsidian, which is another type of igneous rock, and you're going to use the mass and the volume to find the density.